Solar cells in a panel convert light energy from the sun to electricity in the form of direct current. The use of solar panels is now NASA's preferred choice of providing power to space missions. Nuclear power was used in the Pioneer, Voyager, and Cassini missions in the form of plutonium-powered batteries, and is still the only option for some deep space missions, such as New Horizons, which explored Pluto and its satellites. However, plutonium is expensive, and the United States is facing a severe shortage of plutonium as a result of reduced domestic production. In addition, the nuclear-powered option can cause severe damage to humans and the ecosystem in the case of failure during rocket launch. For all these reasons, the use of solar panels is now NASA's preferred choice of powering space missions. This video is one of many that will discuss some of the various projects where NASA has made use of or is currently using solar panels, starting with the International Space Station, also known as ISS. The International Space Station is powered by an array of solar panels. There are 8 sets of panels measuring 112 by 39 feet. These panels were transported with the Space Shuttle over several missions. The array generates between 84 and 120 kilowatts of power when exposed to sunlight, which is enough to power 40 homes. A portion of the power generated during exposure to sunlight is used to charge batteries, which then power the space station when the arrays are not exposed to sunlight. NASA is in the midst of upgrading the solar panels to boost efficiency and to ensure that there is sufficient power for current and future experiments for a decade. As of November 2020, the International Space Station has been used to conduct 3,000 research investigations by 244 individuals from 19 countries over a 20-year period, according to Newsweek. All these 3,000 research investigations were made possible with solar energy. Another project that I really like is the Juno Spacecraft that was launched from Cape Canaveral Air Force Station on an Atlas V rocket on August 5, 2011. Juno is currently orbiting Jupiter, 480 million miles from the Sun, where the sunlight received by the spacecraft is about 4% what is received on Earth. For this reason, the surface area necessary to generate enough power for the research is quite high at 24 square meters. There are 3 solar panels which generate 500 watts of power. The challenge engineers face with this mission is the low intensity, low temperature environment. Jupiter is the furthest any solar power spacecraft has gone. To ensure that solar panels worked as intended, technicians tested solar cells meticulously for problems associated with working under low intensity and low temperature conditions. Engineers also designed Juno instruments to draw as little power as possible as a means to ensure optimal performance. Other engineering considerations are a mission design that optimizes exposure to sunlight by avoiding Jupiter's shadow and a polar orbit, which minimizes exposure to the intense radiation from Jupiter's magnetosphere. According to NASA, the spacecraft was designed to investigate Jupiter's origins, interior structure, deep atmosphere, and magnetosphere. It is believed that the data obtained with Juno will provide insights into the history of the solar system and how other planetary systems form and develop in the universe. The science done with Juno has been phenomenal in the sense that it has completed its primary mission and provided the most detailed photos of Ganymede, the largest moon in the solar system. All these achievements were made possible by careful planning by NASA scientists with the use of solar energy. I hope you found this information useful. I shall leave all relevant links in the description below. Please like and subscribe on your way out. Also ring the notification bell. Cheers.